Well, welcome back to another 6th grade math prep talk video. In this video, we're going to focus on representing and ordering rational numbers, part 1 of this unit. So we'll introduce the idea of integers and negative numbers. This will be something that is new for your 6th grade students. They've never dealt with negative numbers before. And so we'll begin talking about opposites and absolute values, and then work on locating and ordering rational numbers and integers throughout this video as you begin this unit in 6th grade math. So thanks for joining us, and I hope you get something positive out of this video. Our learning objectives for the first part of this unit will be to identify a number, its opposite, and its absolute value. And again, as I mentioned, these will be new concepts to 6th grade. Then we will locate, compare, and order integers and rational numbers on a number line. And we will finish up the first part of the unit by ordering integers from real-world contexts. But we will also discuss in this video how to order rational numbers involving percents, decimals, and fractions as we look at the STAR released questions. Here is a closer look at the standards, or the TEKS, that are associated with those learning objectives. What you'll notice is that the readiness standard 6.2D has been tested 9 times in the last 5 years. So you can expect that TEK to show up about 2 times on every STAR test. The supporting standards that we're going to focus on in this video have only been tested 2 times in 5 years. And so as you're evaluating the effectiveness of your beginning of the unit here, your win really is going to be determined by 6.2D. We obviously want students to be successful in all of the TEKS, but we're really going to focus on 6.2D as the focus of our success. So as we begin this unit on integers and negative numbers and comparing and ordering, we're going to start off by talking about opposites and absolute values. And obviously students will need to know that the absolute value of a number is just the distance that that number is away from 0 on a number line. Also, they obviously need to know that the absolute value of any number is just the positive version of that number. So for example, in this STAR released question, which point represents the value of the absolute value of -1/2? Well, if students are aware that the absolute value of any number is positive, then I automatically know that the number that I'm looking for has to be positive, which means when I identify where 0 is on this number line, I know that it cannot be over here. And that's going to help me eliminate A and B. Then the absolute value of -1/2 is +1/2, and since S is not at +1/2, that means that R would be the correct answer here. I wanted to show you the data analysis from this question. You'll notice that 70% of the state chose B. That is a flat-out misunderstanding of absolute value. That absolute value is always represented as a positive number. And so whenever I have the absolute value, let's say of -4, I know that that's going to be +4, because -4 is 4 units from 0 on a number line. One thing you'll want to remind students is that when we do the absolute value of a positive number, that just becomes the positive version of that number. So it's really like you're just dropping the absolute value bars, because the distance that 7 is away from 0 on a number line would simply just be 7. And so making sure that you're very heavy on the vocabulary and that students are understanding the basic concept of an opposite and an absolute value. This is a really great released question to see if your students are understanding the difference between an integer, its opposite, and its absolute value. So you see that George wrote an integer. The opposite of George's integer is -53. So if I just write that down, the opposite of his integer is -53. From that, I want to be able to determine what the integer actually was and what the absolute value of his integer is. And so what we see is that if the opposite is -53, the integer had to be positive 53, because the opposite of 53 would be negative 53. And then the absolute value must always be the positive version of that, which will be positive 53. And so going through these statements, what we see is that Roman numeral 1 is true. Roman numeral 2 cannot be true because the absolute value can never be a negative value, so Roman numeral 2 is wrong. The integer is negative 53. That is not true because the opposite was negative 53, which means that the integer had to be positive 53. So this one is wrong. And then the integer has an absolute value of 53. That is a true statement based on what we wrote here. And so letter D is going to be the correct answer. You need to decide as a PLC, are you going to force students to write this down for every problem? I think it's probably a good idea. Some students may not necessarily need to do that, especially as they get more comfortable, but I think definitely in the beginning, you'll want to heavily consider having students write out this information as they are trying to identify these three things. As we move into the next TEK, 6.2c, it tells us that students must be able to locate, compare, and order both integers and rational numbers using a number line. And so in this particular released question, what we see is that we have both negative fractions and positive fractions, and we will want to locate those on this number line so that we can figure out which one is not correctly placed. By the way, before I keep going, I want to let you know that this is the perfect TEK to set up as a hotspot. So instead of having students choose one of these four answers, it might be locate on the number line by choosing where it would go on the number line. And so just think of that as a possible hotspot, and we'll create those and have those available for you in the curriculum. Now, when we look at this question, what we notice is that point P is negative 24 over 3, or probably better known to your students as negative 8. So we want to see, is point P actually at negative 8? Well, we see here point P located at negative 8, and so that is correctly placed on the number line, which means it is not going to be the answer for this particular question because we are looking for which one is not correctly placed. Point Q is at negative 9 over 2. Well, students are going to need to know that that's really the same thing as negative 4.5. And if we look at negative 4.5 is between negative 4 and negative 5. That would be right here at negative 4.5. Point Q is not at negative 4.5. It is at negative 3.5, and so Q is not correctly placed on this particular number line correctly, and so that would be the answer in this particular instance. Now, if we kept going, we would see that point R is 3.5, and I see that point R is at 3.5, halfway between 3 and 4, and point S, 15 divided by 3, which is better known as 5, and S is located at positive 5. And so H and J could not be the correct answer. The misconception here is that negative 3.5 is really between negative 3 and negative 4. Or I'm sorry, that negative 4.5 is between negative 3 and 4, but it's not. It's between negative 4 and negative 5. And so you'll want to make sure that a number line is present somewhere on your notes, somewhere in your classroom, because you'll always want to be pointing back to it and reminding students of where these numbers fall, especially the negative numbers on the number line. For this released question, we'll notice that we're trying to find the point that best represents the fraction 1/3. And so again, remembering those benchmark fractions, having sixth graders continually remember that 1/3 is the same as 0.33 repeating or 0.3 repeating. That way that they'll know how to find this on this particular number line. Now, what we notice is that this number line is not very nicely labeled. What we do see is that the end of it is at 0.5 and the beginning is at 0. So this number line covers a distance of half of a unit. And so I'm going to start there in my numerator with 0.5. And then what I notice is that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 partitions of this number line. And so we're going to divide that distance that it covers by those 10 partitions, and that is going to give us 0.05. Dividing by 10 just moves that decimal place one spot over to the left, and so that tells me that each of these are going to be 0.05, and so 0.05 there, add 0.05 to get 0.10, then 0.15, then 0.20, 0.25, etc., all the way up until I finish off at 0.5. And so what we're going to see as we fill this in is that 0.33 repeating is going to be between 0.30 and 0.35, or 30 hundredths and 35 hundredths. And so M is going to be the correct point that best represents 1/3. And so again, making sure that students are continuing to see those benchmark fractions, know their representations both in percents and in decimals. That way they can locate, compare, and order successfully on this standard. 6.2D has been tested 9 times in the last 5 years. This is a readiness standard, and so we want to make sure that we're giving students adequate practice on this standard. They have to order a set of rational numbers, meaning it could be fractions, it could be negative numbers, it could be negative fractions, and usually it will be arising from mathematical or real-world context. And so as we see this problem, Akeem created a list by correctly putting a group of fractions, percentages, and decimals in order from least to greatest value. That is really important that students are reading carefully to know if they should be putting this from least to greatest, or in some cases from greatest to least. So it's really important that they're identifying that early on. Now, if we just start with letter A, what we see is that we have 0.21, so 21 hundredths, and then we have a percentage, 22%. Well, I'm going to want to convert that to a decimal so that I can a little bit easier compare. And so 22%, we know from previous skills, is going to be 22 hundredths. Then 1/4 is a benchmark fraction. We need to just know that 1/4 is 25%, or 0.25. I'm going to separate those a little bit with a line there just so that it's a little easier to see. And so what I notice is that so far I'm so good. I've got a number as 21 hundredths, and then 22 hundredths, and then 25 hundredths. Then I go to the next number, that's 35 hundredths, or 0.35. That one is in the correct order. Keep going, 38% we know is going to be 38 hundredths, or 0.38. That is also greater than 0.35, and so right now, letter A is looking really good. And then I get to the last number, 3/8. And hopefully students remember how to count by eighths, but if not, then they can come over here and divide 8 into 30. And with a decimal there, because we know we really divided 8 into 3, and 8 goes into 30 3 times. Times 8 is 24. That leaves me with a remainder of 6. 8 will go into 67 times. 7 times 8 will be 56. And then 40, 8 goes into 45 times. So I know that 3/8 is really the same thing as 375 thousandths. Well, that number is smaller than 0.38. So we got really close, but unfortunately we kind of fizzled out at the end on letter A. But what I know is that if I can find an answer choice that's close to A, just with these two numbers flip-flopped, then I'm going to find the correct answer. And so if you look carefully at letter D, this has all of the same first 4 numbers, and then it does in fact switch those last 2 numbers so that 0.375 comes before 0.38. And so letter D is the answer choice that has these 5 numbers, or 6 numbers, in the correct order. For this question, I noticed that I have a mixture of positive and negative numbers, and I want to put them in order from greatest to least value. So again, starting with the largest number, working my way down to the smallest number, and remembering that those Big numbers that have a negative in front are actually small, and we'll talk about that more here in just a second. So as I look at these numbers, I'm just going to start with F. Each of these 4 answer choices have the same set of 5 numbers. And so negative 19 divided by 2, putting that in as a decimal or as a mixed number if you'd like, would be negative 2 goes into 19 9 times with 1 left over. So that's really negative 9 1/2, or you could write it as negative 9.5. Then we have negative 3 1/4. There's not really much we want to change with that, so we can just leave that as negative 3 1/4. Negative 1.2. And then 38 over 6, we may want to change that so that it's a little easier to understand what that number really is. And so 6 goes into 38 6 times with 2 left over. And so 6 2/6 will simplify to 6 1/3. And then finally we have 7. Now what you'll notice is that just based on letter F, we actually wrote these numbers down in least to greatest value. And so if you have students that are choosing F as the correct answer, then it means that they did not actually read or understand what was meant by greatest to least value. So what that means is that in order to get this from greatest to least value, we actually need to go back up the list that we wrote this in. And so this would be 7, 6 1/3 would be smaller than that. Negative 1.2 would be smaller than that. Negative 3 1/4 would be smaller than that. And negative 9 1/2 would be even smaller than that. And so answer J is going to be the correct answer. Now the misconception you're going to want to look out for here is found in letter G. You'll see that this is 7, this is 6 1/3, this is 9 1/2, this is negative 9 1/2, this is negative 3 1/4, this is negative 1.2. And so students thinking that a large number but with the negative in front should go before a smaller number with a negative in the front is the misconception. So again, having that number line written down or drawn out or displayed somewhere in your room so that they can actually see negative 9 is going to be down here, negative 3 is going to be somewhere in here, negative 1 is going to be somewhere in here, and then 6 and 7 will be down here so that they can actually see greatest to least is going to go this way. So I'm going to have 7 and then 6 1/3, negative 1.2, negative 3 1/4, negative 9, so that they can actually visualize. That's going to be a really important part of getting them to master this TEK. I'm not going to necessarily work out all of these problems from start to finish for you, but I do want to point out a trick that you can use sometimes on these problems, which is a half trick. And so if you'll notice here, we have 9.5 as one of our numbers. We want to put these in order from greatest to least. These are all positive numbers, so I don't have to worry about anything being negative here. Now, if I look at 9 3/8, is that bigger or smaller than 9 1/2? Well, if I just look at the 3 over 8, half would be 4 over 8, so that means 3 over 8 is smaller than a half. And so 9 3/8 is going to go on this side of a half. Then 9.125, so 9 125 thousandths, well, that is also smaller than a half, 9 1/2, so that's going to also go on this side, 9.125. And then 9 3/4, well, I know that 3/4 is 0.75 or 75 hundredths, and so that's going to be bigger than 9 1/2, and so that at least helps me start off trying to put these numbers in order. So I know that I should see 9 3/4 being greater than 9.5. And so 9.5 is here. We want 9 3/4 to be greater. It is. So that at least is a possible correct answer. Then from here we see 9.5, but we see 9 3/4 over here. We want it to be from greatest to least, so we know that one can't be it. 9.5 is here. 9 3/4 is on the right side of it, and we want it to be from greatest to least, which means that that can't be the right answer. And then here is 9.5. Here is 9 3/4, so that's good, but this is 9 3/8, and so they're saying that 9 3/8 is greater than 9 1/2, and we determined just based off of this that that cannot be true, and so letter F is the only reasonable answer here. In this real-world context, we're given 4 portions that a student used to build a website, 4 portions of a day. And so what we notice is that the first 2 numbers are in percents, and the last 2 numbers are in fractions, but they are fractions that can easily be converted to percents. For example, here, if we were to put this over 100, we know that just to get that into a percent, we would multiply by 4. And so multiplying 7 by 4 would give us 28 over 100, which would be 28%. Then Blake is 3 out of 10, so that is pretty clearly 30%. And so now we can compare this just by looking at them as 4 percentages. And we want this to be from greatest amount of time used to the least amount of time used. And so the biggest percentage there is going to be Andrew. He's going to be first. The second is going to be Blake with 30%. So Blake is going to come in second. And automatically I see that I'm done, because the only one that has Andrew and Blake as the first 2 positions is letter F. If you kept going, next would have to be Jamail and then Ernesto, and that matches up with what letter F says. For this problem, we're given 6 fractions, and what I notice about the denominators of all of these fractions is that it's going to be best to compare these if I make the denominators 32 for all of them. And so if we start with the first fraction, to get to 32, we would need to multiply by 2, and so this is going to be 14 over 32. For the second fraction, we would need to multiply by 16. 2 times 16 is 32, and so 1/2 is going to be 16 over 32. For the third fraction, we would need to multiply by 4, and so that's going to be 12 over 32. The fourth fraction is already in terms of 32 in the denominator. Then 5 over 16, we would have to multiply by 2, so that's going to be 10 over 32. And then finally 15 over 32. Now in this case, we want to put the numbers in order from least to greatest, so starting off with the smallest number of 32. So we have 14, 16, 12, 9, 10, and 15. And so the smallest there is going to be 9 over 32. So that's going to be the first number, which tells me it's either G or J. Then next would be 10 over 32, which would be 5 over 16. And that is letter J. And so we see automatically that we're going to get the answer here pretty quickly. If we were to keep going, the next one would be 12 over 32, which would be 3 over 8. Then 14 over 32, which would be 7 over 16. Then 15 over 32. And finally 16 over 32, which is 1/2. And all of that matches with what we see in answer choice J. The last problem we'll look at involves positive and negative decimals. And again, this is going to be really helpful for your students if you model this by putting it on a number line. And so what I see here is that I need -1, really all the way up to about 3 here. And so it doesn't have to be perfect. It's just sort of a sketch to figure out what exactly is going on. And so -1.01 is one of the numbers that I see, -0.3, 3, 2.91, etc. So I'm going to just start off with some of the easy ones. So for example, ties is at 3. And so this right here is going to be ties. 2 and 91/100ths, well, that's going to be a little less than 3. So this right here is going to be my shoes. And then let's see it. The rest of the numbers are negative. So if I go to watches, I've got -0.3. So I know that -0.3 is going to be on the left side of 0. -0.3 is going to be right about here, and that's going to be my watches. -0.9 is going to be a little closer to -1, so -0.9 is going to be here, and that's going to represent my shirts. And then finally my pants is -1.01, which is on the left side of -1 on my number line. And so -1.01 will be my pants. And so what I see is that we're going to have pants, shirts, watches, shoes, and ties in that particular order. And so examining my answer choices, we see that A is going to be the best choice. So for 6.2D, I just went through and counted up how many questions only have positive numbers, how many have positive and negative numbers, and how many of the questions involve fractions and percents. And so you're going to see there's a very nice mixture of problems that have been released on STAR for this particular TEK. And so you're going to want to make sure that you're doing questions that have a different variety to them, and certainly our curriculum will follow that guideline as well. If you guys have any questions on part 1 of comparing and ordering rational numbers, you can feel free to reach out to me, Ryan Castle. There, my email address is listed, or our middle school facilitator, Paris Scott, would love to answer any of your questions as well. And as always, before you go, make sure that you fill out our survey so that you can let us know that you watched and help us to better serve you in future videos. Good luck to you and your students as you start off this comparing and ordering rational numbers unit.